Alright everybody, here's part 2 of my summary video on arithmetic and geometric sequences. I'm doing part 2 because I don't like to make the videos longer than about 20 minutes or so, 20-25 minutes if I can, so I stopped the other one and I'll continue what I wanted to say in this one. Now so far here's what I've done. I've told you I wanted to make a summary video. I wanted to talk about all the formulas and concepts involved in this sort of thing and show you an assortment of examples. That was my goal. And so far, I've done all my problems with arithmetic sequences. Okay? All right, so that we went all the way up to this one where we had an arithmetic sequence and so on. Now, let's talk about the geometric sequence. The definition first. A geometric sequence is a sequence, which is a list of numbers, where any term is the previous term multiplied by some fixed number. That's the definition. That's what it is. Verbally, I can express it that way. In terms of a formula, I can say an is an minus 1 times r. R is that fixed number. In a geometric sequence, we always label that fixed number by the same letter, which is r. In an arithmetic sequence, there's also a fixed number, and we always label it d. Okay, so in a geometric sequence, this formula says term n equals term n minus 1, which is the term that came right before it, times this fixed number r. R is called the common ratio. Now, and then from there, I have some formulas that I can use to do calculations. Before I talk about the formulas, let's look at an example, and then maybe we'll look back and decide which formula we should use. Okay, so let's see. First problem I want to do is over here, like so. So this one just says we have a sequence, doesn't say what kind it is, and then I have 3 questions. One, what kind of sequence is it? Is it a geometric sequence? Is it an arithmetic sequence? Is it neither? Because could have some sequence where the numbers are completely random and there's no pattern to it, but that's the first part. So let's look at this. I'm going to answer question 1 right here. So let's address whether it's arithmetic. So in an arithmetic sequence, you find any term by what? Taking the previous term and adding some fixed number. So let's look at it like this. First, if I'm going to consider if this one might be arithmetic, then I would take like -1 plus some fixed number d, and I would get 3. Like that's how it is. That you would take any term and you would add d, and you get the next term. Now, if I take -1 the first term and I add d and I get 3 the second term, then that would make d equal to 4, right? But would this pattern continue? If I take the second term and add 4, am I going to get the third term? So let's see, second term is 3. If I add 4, I'm going to get 7. I'm not going to get -9. And if I take -9 and I add 4, I'm not going to get 27. So it's not arithmetic. Okay? If I figure out what number you have to add to any one of these terms to get the next one, that number is not going to work to get you from any of the other terms to the one that comes after them. Okay, so no, it's not arithmetic. Could it be geometric? Let's see. Geometric. We just talked about the definition of that. And we said that you take any term times some fixed number r, and you get the next term. So the way that works is -1 times r is equal to 3. The first term, -1 times r, this potential fixed number that you multiply any term by to get the next one, gets you 3, second term. If I solve for r, that would make it -3. Okay, now, is it true? Can I put this to the test? Is it true that if I multiply the second term by -3, that I get the third term? Is that true or not? Let's say times -3. What's 3 times -3? It's -9. Okay, let's try it one more time just to make sure. If I take -9 times -3, am I going to get positive 27? Yes, I get positive 27. So it is geometric. There's my answer. And r, this fixed multiplier this fixed number that you multiply any number by to get the next one is negative 3. So there's my answer to question 1. And then here's my answer to question 2. Question 2 is, what's the common ratio? Well, question 2 gave away the answer to 1, but that's the way I did it, all right? Only a geometric sequence has a common ratio. It's built into it. It's all based on the meaning of it. Any term is the previous term times the common ratio. Anyway, okay, one last thing. What's the sixth term? Now, of course, if I wanted to, if I was inclined to do it this way, I could keep multiplying each term times negative 3 and getting the next term until I got the sixth term, which is what the third question's asking me for. Okay? But I want to show you the formulas, and so I'm going to do it this way. Let's see. Let's go back and look and see if there's a formula that will allow us to directly calculate the sixth term. Okay? So here I've got the definition to a geometric sequence. I got this formula that will calculate the sum of the first so many terms of a sequence, and I got this formula that will let us find any term we want. That's the one that would potentially let me calculate the sixth term directly. And when I say directly, I mean it would let me calculate the sixth term without having to write out all the numbers that came up to it. And I guess if that's the way you want to do it, there's nothing wrong with that, but it's not the way that I'm going to do it now. Okay, so let's see. Here we go. For part 3, that formula was that AN is equal to AN is equal to A1 times R to the power n minus 1. Okay, I'll use that to calculate the sixth term directly. So if I wanted the sixth term, I would let n be 6 in this formula. You would say A6, the sixth term is A1, which is negative 1, times R, which is negative 3, to the fifth power. The power is n minus 1. In my case, I'm letting n be 6 to find the sixth term. So 6 minus 1 would be 5, like that, okay? All right, let's see what that is. Let's see, negative 1, I forgot it was negative 3 to the fifth power. That's what I don't remember. So it's 243, okay? All right, A6 is equal to positive 243. All right, there's all my answers. This sequence turns out it was geometric. R is negative 3, and I calculate the sixth term directly with one of my formulas. It's on my formula page, 243. All right, so one down. Let's look at a few more. Here's a have versus a want question. Let's see this. So suppose we have a geometric sequence. First term is 7 and R is 4. Can you find a formula for the general term? Okay. And then can you find the seventh term? That seems a little bit like the last one, but let's see. Here I know it's geometric, so I know which formula to use. So it was AN is A1 times R to the n minus 1. That's the formula for the general term. And I have every number I need to complete this. Okay? It will say AN is equal to A1, which is 7, times R, which is 4, to the power n minus 1. Now there's the general term formula. I can't simplify or reduce that any further than it already is. Okay, I can't say 7 times 4 and get 28 because the 4 has the power applying to it. And so it's like locked in there with the power. I can't multiply by 7. But there's nothing I can do. I just have to leave this one the way it is. Okay, but I could use that to calculate the seventh term directly. All right, so it will say the seventh term is 7 times 4 to what power? Be the sixth power. So let's see. That's going to be a big number. 7 times 4 raised to the sixth power turns out to be 28,672. Okay, so the seventh term of this sequence, 28,000, what did I say, 672. All right. So in a geometric sequence, the numbers can get very big very fast because of the multiplication. Think about what you're doing. I know I've answered the question, but I want to show you things as much as I can. So I can say this, that the way this sequence would look is that 7's the first term, and I multiply 7 by 4 to get the next term. That's 28. but I got to multiply every term by 4 to get the next term, so that's what the numbers get so big so fast. 28 times 4 is 112, and you can imagine that if you kept multiplying by 4, getting the next term and so on, that eventually the numbers would get pretty big, and it might not take very long to do it, right? So here we go, the 7th term is that big. It's 28,672. All right, let's look at another one. Here we have a geometric sequence the way that it is. It's 4, then negative 12, then 36, then negative 108. What's the sum of the first 14 terms of that? Okay, all right. So it's like saying I don't know what the 14th term is. I haven't figured it out yet, but there is a 14th term, and what's 4 plus negative 12 plus 36 plus 1 negative 108? Keep going all the way to the 14th term, and you add them all together. That's what sum means, what you get when you add stuff together. So let's see if there's a formula on my formula page to accomplish that for me. So look at this under my heading for geometric sequence. I've got the definition, and I've got this one. This is the one that will do exactly what we want in this question. It'll calculate the sum of the first n terms of the sequence. Okay, there it is. That is what we want this time. So let's see. Now I will do this directly. I will use this formula. Sn is for geometric sequence. The sum of the first n terms is a1, 1 minus r to the n power over 1 minus r. Okay, I will use this, but in principle, I guess I could figure out what r is, write this out 14 terms big, and then add them all together. I could do it that way. I would accomplish the same thing as I am with this formula. I'd say, why don't I just do it that way? Well, because part of the class is learning the concepts and formulas that are related to all the subjects. Okay? All right, so yes, I'm going to use the formula even though there are other ways to do it. Well, look, in this formula, what do I need? The first term, and I need r, and I don't know what r is. Okay? But look, you could take any of these numbers and see that you multiply by r to get the next one. You could use that fact to solve for r. It looks like r is going to be negative 3. 4 times negative 3 is negative 12. All right? Maybe you could figure that out just by looking at it also. But for me, I want to solve for it on paper. I feel better if I do it like that. So look, I need to know what r is. And it would be true that since this is geometric, 4 times r gets you negative 12. And negative 12 times r gets you 36. Doesn't matter which pair of these numbers you focus on. Just realize that that's how it works. You see? So I wrote down 4 times r is negative 12, and then I'll solve for r, and I'll get negative 3. Negative 12 times 4 is negative 3. Okay? All right. Now, I would have gotten the same answer if I would have done negative 12 and 36. If I would have written down negative 12 times r is 36, I still would have gotten the same thing. Just pick 2 of these and write down the equation that's applicable between the 2 of them. All right. Now, that's everything I should need. Let's see, first term is 4, then I get 1 minus negative 3, and if I want the sum of the first 14 terms, I will let n be 14, okay? So power 14, close the parentheses, and then 1 minus negative 3. That's what it would look like putting my numbers in. 4 for the first term, negative 3 for r. Now, sometimes when students ask questions by email or whatever, they have trouble using their calculators, and if you've got a real simple calculator and you're not getting the right answer as you're practicing, it might be best to just do things in steps. So I'll show you what I get if I do things in smaller steps. So first I'll just calculate, what's 1 take away negative 3 to the 14th power? I don't happen to know what that is, but according to my calculator, it's 4,470,000 or 700. Oh, sorry, 4,782,968. 968. Okay, that's that number. And still I've got this multiplying by 4. And what's this down here? What's 1 take away negative 3? That's going to be positive 4. All right, so here's where I am. Now, I could multiply 4 times negative 4 million, so on. But you know, it's like you just cancel the 4s just as easily. So I will do it that way. All right, so cancel, cancel, and I get my answer. The sum of the first 14 terms is negative 4,782,968. Okay, and then I'm done. I've got my answer. All right. So let's compare this one with this one, okay? Because I see some similarities between them, but this one does look different, at least at first glance. Now, I did a problem in my initial video on part 1 of this where I had summation. Like, this is called summation. That's the summation symbol. And I started by just writing it out. How about this? Let's write this out, see what it looks like. So that helps some people. It couldn't hurt for me to do it right now. But all right, the way this works is I start with 1. I put 1 into this formula. That would say 7 times 2 to the first power. That's just 14. And then I add. Okay, and the next number is what I get when I put 2. I count from 1, 2, 3, all the way up to 10. So now I'm at 2. So 7 times 2 to the second power. That's 7 times 4, so that's equal to 28. And you would keep going, and then you would stop at 10. All right? Now, I don't know what 7 times 2 to the 10th power is, but it's a big number. And it turns out it's 7,000, a little over 7,000, 7,168. Okay, so that's your 10th term. That's what the whole series is. I could calculate the result of this if I had written down every number up until that very last one and added them all together. I can do it that way. But let's say that I know that this one's geometric. Say that it's given in the problem that this happens to be geometric. Does that allow us some kind of shortcut? Like, is there some other way to do this besides writing it all out? Almost every problem that I've done that involves a sequence or a series, we could answer if we just had the patience to write the whole thing down and do whatever we need to do. So with this one, like, is there some shortcut, some way that I could calculate this without writing down all 10 terms of this and then adding them together? Well, let's look at our formula page. Where is it? Okay, so over here, yes, again, for a geometric sequence, there is a formula to calculate the sum directly. It turns out then, because this is geometric, it's the same formula. We're still just trying to find the sum of, this time, 10 terms, okay? So here, there are 10 terms. It is a geometric sequence, and so there's my applicable formula. All right, so here's what I'm trying to figure out. What is sum of the first 10 terms? S10. Take the first term, which is 14. 1 minus r. What's r this time? Okay, it's geometric. Can you tell me which number you multiply every term by to get the next one? It's 7. Okay, or sorry. It's 2. So 2 to the 10th power over 1 minus 2. There it is. It's a geometric sequence. First term is 14. R is equal to 2. Okay, so I use this same formula. Even though these look different, sound a little bit different when you read them, they're the same kind of question. All right, let's figure out what this is. 1 minus 2 to the 10th power. So that turns out to be negative 1,023. Again, I'm going to do this in steps because that's what some people have trouble with. So there is just this number, 1 minus 2 to the 10th power. And the way I'll do this is I'll, how about we take 14 and we'll divide the negative 1 by that. So we'll get negative 14 and times negative 1023. All right, so let's see. That turns out to be 14,322. Okay, So that's what you get if you take 14 plus 28 plus all the way to 7,168. You'll get 14,322. Okay. All right. Then we're done with that one. So let's look at one last problem. All right. Now this one is off the charts in a way because even though this is a geometric sequence that we're dealing with here, it doesn't, there's no formula on here that directly tells us what we are looking for this time. Because this time it says you know that it's a geometric sequence, and you know the second term and the seventh term. What is the sixth term? Okay? All right, so yes, mapped it out for you, hoping that you could see a little bit better what we're dealing with. We have a geometric sequence. I don't know the first term. Second term is negative 1.5. I don't know the third, fourth, fifth, or sixth term, and then the seventh term is 0.046875. Okay, now, yeah, there's no formula that I've given you, okay? Neither of these that will directly tell you what you want, which is the sixth term, okay? But we can think about how this should work. How should this work? That you multiply every term times r, and then you get the next one. So something like this would be true. Multiply times r, get this one. Multiply times r again. Multiply times r again. Multiply times r again. Okay, that's how you could get from the terms one to the other. And we have to do it that way. We have to use the information that we have. And I know the second term and the seventh term, and I know it's geometric. So that would allow me to do this. If I take negative 1.5 and I multiply it by r 1, 2, 3, 4, 5 times, then I will get this seventh term 0.046875. Okay? All right. Now we'll solve for r, but that's my operative equation. That will allow me to find out what r is, this number you multiply any term by to get the next one. So you see how when I mapped it out, I said the sequence looks like this, then it looks like you're making 5 jumps, right? And that's what this exponent is right there. But to get from this term to that term, there are 5 jumps of multiplication. Because they're jumps of multiplication, that is an exponent. This says you take negative 1.5 and you multiply by r 5 times, and you get this other number. Okay, so let's see then. Let's figure this out. How would you solve this? I would first divide by negative 1.5. So I get 0.046875. And I would divide by negative 1.5, okay? And I could figure out what that number is with my calculator, but I won't do that yet. I'm just going to leave it. And I can use my calculator in a second. What would you do after that? How would you deal with this exponent? What's the opposite or the inverse of the fifth power? It would be the fifth root. So you take the fifth root of whatever this is. Okay, so I got 0.046875 times negative 1.5. I'll take the fifth root of that. All right, so here it goes. So I'm going to do, I should have done this beforehand, but here I go. I'm going to have to use my calculator. So to do this in steps, the number in there, and again, I'm doing this in steps because that's what some people need to see, is negative 0.03125. And then I'm going to take the fifth root of that, which I also do in my calculator, and I get negative 0.5. R is equal to negative 0.5. Looked like it was going to be complicated with these numbers, but fifth root of this is negative 0.5. Now, so that's the number I multiply every term by to get the next one. That's an important number to have if it's a geometric sequence. That's not the end result. This is just a means to an end, though, because my question is, can you find the sixth term? So, okay, I I want to know the sixth term. That one right there. What's this number supposed to be? Well, think about it. I now know r. I now know the number you multiply any term by to get the next one. So look, I know the seventh term. How many jumps from the sixth term to the seventh term? Isn't it true that all you would do is the sixth term, okay, whatever it is, if you multiplied it by negative 0.5, you would get the seventh term. That's how it works. 0.0468. Oh, come on. All right, well, this is a little messy, but I want to write that number right there. Okay? So then the sixth term is just 0.046875 divide by negative 0.5. All right, and then that's our answer. That'll be our final answer. So let's see what that is. 0.046875 divided by negative 0.5, and I'm going to get, there it goes, negative 0.09375. That's what I wanted. Question was to find the sixth term. There it is. I had to figure out r first, then use that, but sometimes the first number you get when you try to solve a problem is just a means to whatever the final answer turns out to be. Anyway, okay. So there you have it. There's my assortment of problems. I hope it's helpful to see a mixture of everything. I hope it's also helpful to see all the definitions and vocabulary and formulas in one place. As always, if there's anything else you need help with, let me know.